Hello, 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 mathematicians. This is a Unit 6 review for 4th graders using the Math Expressions program. And I wanted to start off with one of our conceptual understanding pieces where if you look on your review on item 3, asks you to explain how to change 11/4 to a mixed number. Well, explain can mean a lot of things, but what they don't want you to do is just plop a mixed number and an equal sign on there. So if I'm going to explain, let's see how I'm going to start. Well, when I think of 11/4, in my mind, here we go. In my mind, I'm imagining some shape cut into fourths, and then I can mark out the fourths. 1, 2, 3, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths, 11 fourths. So that's the visual I can use to help me explain. When I think about converting 11/4 into a mixed number, one way I can think about that is to create a chain of unit fractions. So I can look at this and see that every whole has 4 fourths in it, or 4 groups of 1/4. And that's one whole. Oh, a little messy, but we get the idea. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to run out of space. 9, 10, and there's my 11/4. If I count that out, I can group it knowing that 4 fourths is one whole, so this is 1. 4 fourths is one whole, this is another 1. And then I have 3 fourths, and that can't be grouped into a whole, and I can see that in my picture. If I do this kind of the long way here, I can see I have 1 plus 1 plus 3 fourths, so 11/4 may be equivalent to 1 whole and 3 more fourths. The shortcut version of this might be to do a quick division problem where I realize, okay, there are 2 groups of 4 that I can pull out of 11, 8, 9, that leaves a remainder of 3, and if we think of that as a fractional remainder, oops, this should say 2 up here. I am so silly. I said 1 plus 1 a couple of times, and then I wrote a 1 up there. 1 plus 1 is going to be 2 today. And back down here, we're going to have that 2 whole and then a 3 fourths remainder. Same idea. So 1 plus 1 is 2, and then 3 fourths more. Messy, but hopefully you get the idea. There are a few different ways that we can explain that or conceptualize it. Next, we're asked to do some stuff with writing a fraction as a product. And product, of course, when I look at that word product, I immediately think, okay, we're talking about multiplication between a whole number and a unit fraction. Now, what I remember about unit fractions is that a unit fraction is always 1 out of whatever I have. 1/4, 1/20, 1/1,000,000th, doesn't matter. 1 unit out of the fractional pieces that I'm working with. So down here, if I have 5/9, that means I'm going to have some groups of a unit fraction. Now, since I see here I'm dealing with ninths, I think my unit fraction will be 1/9. There's no reason or any way that I could change that I have a whole that's broken into 9 parts. Now, how many 1/9 I have is where I look at the numerator. And if I broke that out into a string, I would see I have 5 of them. So 5 groups of 1/9. Okay, mathematicians, for you it's been about 2 seconds, and for me it's been about 24 hours. Here's the rest of the tutorial. Item 13 has us multiplying a whole number and a fraction. Now, I find it really helpful not to think of this as 5 times 4/7, but to go back to the idea that when we talk about multiplication, we're talking about groups of, right? So if I think of it as 5 groups of 4/7, then in my mind, I can see 5 groups of 4/7. And once I see that, then I have a pretty good idea. Okay, so what I'm counting in is still sevenths. That's not going to change. What I do have to think of is 5 groups of 4. Well, I know my math facts, and I know 5 groups of 4 is 20. Also in my mind, when I see this stuff down here, I can count it out: 4, 8, 12, 16, and 20. Now, you may leave it like this unless you're asked to simplify. And that's when we're going to want to say, okay, well, let's go for a shortcut here. We're going to want to find out, well, how many groups of 7/7 can we get out of 27? Well, we can find that out by dividing 20 by 7. We can get 2 groups, or 14/7 out, and that leaves us with 6 out of 7, or 6/7, the fractional remainder. And depending on the directions that you get for this kind of work, either one of these they'll totally go. All right, item 16 has us adding 2 fractions. One thing that's interesting is here we've got a fraction greater than 1, 12/7. Now that doesn't matter for the moment. We can just add our sevenths together. We're counting in sevenths, and 12 plus 5 is 17. That part's not so bad, but again, most of the time you're not going to leave a sum or a product as a fraction greater than 1. You're going to want to simplify it or convert it into a mixed number. So I can look at this using division, or I can say to myself, all right, well, how many groups of 7/7 can I get out of 17/7? Well, I can take one group of 7/7 out, and I've still got 10/7, so I can take another group of 7/7 out, and that's 14/7. That leaves me with only 3 more 7s, which means I have 1, 2 whole, plus 3/7 more. Or I can go the traditional route. Either way, I am looking at a mixed number of 2 3/7. All's well that ends well there. All right, let's go ahead and take a break here, and in part 2 we'll do some more addition and subtraction with fractions and mixed numbers.